In this video, we will learn that what is LLVM, what are the benefits of using LLVM. The short answer of this question is that LLVM is a framework that can be used to develop compilers, and it maximizes code reusability, making compiler development easy and effective. But we want to really understand that what is LLVM. To that end, we first have to know about the phases of compiler. You might already know the phases of compilers from the compiler construction class. However, let's just go through the phases of compiler once again quickly. So we know that the input to a compiler is a source file, which usually compiler takes as a stream of character. First phase of compiler is lexicon analyzer. It converts streams of characters to streams of tokens. Tokens are meaningful information for compiler, and they also have identifier associated with them. The next phase is syntax analyzer, where we create abstract syntax tree. Subsequently, we do semantic analyzer phase, where syntax tree get annotated and more information is added in the syntax tree. The last phase of the first part of compilation is intermediate code generation phase. The output of this phase is intermediate representation, also known as IR. Afterwards, this IR goes through an code optimization phase, where we reduce the size of IR and we try to increase the performance of IR, making it consume less RAM and less CPU cycles. In the next phase, we generate assembly code, and in the final phase, we optimize this assembly code. Now here is the key concept, that these phases can be divided into front end, middle end, and back end. The front end is language dependent and the back end is machine dependent. So the input to our front end is stream of characters, and the output of the front end is IR, whereas input to the middle end is IR and output to the middle end is optimized IR. Finally, the input to the back end is optimized IR and the output to the back end is optimized assembly code. If you have understood this language dependent front end and machine dependent backend concept, then you can really appreciate what is LLVM. So LLVM provide us an API that takes input abstract syntax tree or any other intermediate representation, and it generates LLVM IR. So you can say that the LLVM API is at the intermediate code generator phase, and LLVM IR is the output of that intermediate code generator phase. Subsequently, the LLVM optimizer is called, which is also known as OPT. The LLVM optimizer is the middle tier program. It optimizes the LLVM IR. So LLVM optimizer is at the middle tier. Then there is a LLVM backend, and that supports many existing platforms. Now the next question we should answer is that why LLVM stands for low level virtual machine. So the answer to this question is that it might be started as a virtual machine, but it is no longer a virtual machine but a framework that help us to develop compiler quickly, and it is called low level because the IR that it supports is of low level, in contrast to the intermediate representation provided by Java virtual machine, where the bytecode of Java virtual machine is not low level but quite high level, and it has many of the high level concepts of Java embedded in it. Now you should ask that what are the benefits of using LLVM? First, recall that our front end is language dependent and our back end is machine dependent. So at front end there are many languages that are developed to support LLVM IR, such as Clang is a front end of C language, and Clang produces LLVM IR. Similarly, Clang++ is a front end of C++ language and it produces LLVM IR. We have Go LLVM, which is front end of Go language, and it produces LLVM IR. And also we have Rust C, which is also a front end, and it is a front end of Rust language, and it also supports LLVM IR. So all of those languages front end supports LLVM IR. Now the advantage of supporting LLVM IR is that they can all use several optimizations provided by the LLVM optimizer tool known as OPT. Another advantage is that there are almost all the platforms that support LLVM compiler at their backend. So if we generate LLVM IR, then our intermediate code can be compiled for all of those platforms. For example, there is a backend of LLVM compiler for ARM machine, x86 machine, MIPS machine, and so on. So number one advantage of using LLVM is for the language developer. A language developer has to write only the front end, and by writing only the front end he can get all the optimizations of the middle end for free, and it can support his language on all the dozens of platforms for free. So our language developers don't have to write middle end or the back end, he only has to write the front end. Similarly, if there is a new platform being developed by a company, that company can provide support to the LLVM IR, and by this way all the languages that are producing LLVM IR become compatible for their platforms. Furthermore, if there is new optimization being developed in the OPT tool, then that optimization is beneficial for all the languages and all the platforms that support LLVM IR. So in summary, LLVM implies less effort and high reward and maximum code reusability. Before the end of the video, let's see a small demonstration of LLVM. So in this demonstration, I have created a hello world file using C language. This is my simple hello world file, and then I use Clang front end to create LLVM IR of this file. To that end, I write Clang -s and -emit LLVM and then the file name, and the result is that it generates hello world.ll. Let's open this hello world.ll. You can see that it has LLVM IR in it, but we are only interested in the function code. So the function name is main in LLVM IR we write @ before name of the function, and our function return type is 32-bit integer. It has 4 instructions. The first instruction push something on the stack. The second instruction store something in the memory. A third instruction is a function call to printf, and the final instruction is returning integer of 32 bits. So the next step is that we have to optimize this intermediate code. To that end, we use our LLVM optimizer opt. We write opt -s and -o3. So based upon the flags we set, we can optimize for speed, or we can optimize for size, and we can optimize for both. So -o3 flag optimize for speed. So it's possible that the size of my program might increase, but the speed of my program will also increase. So we compile it. It gives us some error because I must have used -f. So now it compiles correctly. Now you can see that we have hello world optimize LL, and let's see the sizes of these files. You can see that the size of my optimized file is increased because we have optimized for speed. We have not optimized for size. Then we can use the LLVM linking program, which is LLC, which is a linker for C language, and this will create us assembly code. So you can see that output of our linking program is hello world optimize.s. Let's open that file, and you can see that in that file we have assembly code. Finally, we can make an executable of the assembly file by calling clang once again, giving it input an assembly file, and it will generate an executable file a.out, and we can run a.out, and our result is hello world as expected. Note that if we run clang without any parameters, then it will itself call the optimizer, linker, assembler, everything automatically. So that I don't have to perform all of those steps one by one. So let's delete all of my intermediate files, and now I have only my hello world. I do clang hello world.c, and by just doing that I have created a.out. But you should remember the clang is a front end, but in this case it is behaving like a front end, optimizer, and back end and everything. So that's it for this video. In the next video we will see what are the important classes of LLVM and how can we use those classes to create intermediate code. Stay tuned.